Hi everyone, I just wanted to go over some answers to the Quiz 1 for Calc 1512 at University of New Mexico. So the Tuesday quiz, the first problem was to evaluate this difference quotient. So f of 5 plus h minus f of 5 all divided by h, with our given f of x equal to x squared minus 2. So the first thing we want to do is what is our function f of x at those two x values we care about. So those two x values are going to be x equals 5 plus h and x equals 5, because that's what we want to evaluate that function at. So if we evaluate it at x equals 5 plus h, so substituting in 5 plus h for everywhere we see x, we get the quantity 5 plus h squared minus 2, which gives us this, which is then 23 plus 10h plus h squared. Versus if we just put in f of 5, so x equals 5, we get 25 minus 2, giving us 23. So putting those two evaluations into our difference quotient, we see that our numerator becomes 23 plus 10h plus h squared minus 23. So we can divide it by h. So we can cancel out the two 23s and are left with h squared plus 10h. Then factoring out an h and canceling with our denominator, we get h plus 10 is the answer to that difference quotient. So we don't need to do a limit here. We just want to evaluate this difference quotient. So we just want to substitute in the two values for x and then simplify it as far as we can go. So then that gives us h plus 10. So similarly, for the Thursday quiz, we have a different function f of x squared plus 5, and we're evaluating it at 3 plus h as well as 3. So first, at x equals 3 plus h, we are given f of 3 plus h equals the quantity 3 plus h squared, because we substituted in that 3 plus h in for x, plus 5. So then that gives us that we had as 14 plus 6h plus h squared. And then f of 3, just plugging in 3 for x, we get 9 plus 5 gives us our 14. So then putting that into our difference quotient, we got f of 3 plus h minus f of 3 all divided by h gives us 14 plus 6h plus h squared minus 14 divided by h. So we can cancel out those two 14s, and then we're left with 6h plus h squared divided by h. So again, we can factor out an h from the numerator and cancel it with the h in the denominator to give us that this difference quotient evaluates to h plus 6. So we just need to evaluate it, don't need to take any limits, and our answer is h plus 6. So then looking at problem 2, problem 2 was the same for both the Tuesday and Thursday section. So we wanted to know the domain of f of x equals the square root of c squared minus x squared for some positive constant c. So just to recall, our domain are going to be what values of x for which f of x is defined. So what values of x can we put in into f of x and give us a valid output? So it's what inputs give us a defined output, f of x. Versus the range is the values that f of x attains. So given that we have the square root, we know that we must have a positive y value, because we can't do the square root of a negative number. So we see that c squared minus x squared's got to be greater than 0. So that part in the square root has got to be positive. So then we can add x squared to both sides and give us c squared is greater or equal to x squared. So then if we do the square root, we get x is less than or equal to plus or minus c. So since we multiply by the negative, we have to flip the interval. So we have x is less than or equal to c, and x is greater or equal to negative c. We could also see that. So if we started here, so if we subtracted negative c squared over, we have that is less than or equal to x, negative x squared. So then we could take the square root of that, and then given that x is greater or equal to negative plus or minus c, and then we do the same thing there. So we give it the range that x has got to be between negative c and positive c. That is our domain. So the next part is to show that f of x is an even function. So that means we just need to show this. And we want to show this for all x, not just some x equals negative a, or negative x equals negative a. So you want to show this for all x values that could be possible. So if we plug in negative x into x and f of x, we get the square root of c squared minus the quantity negative x squared, which then, evaluating that square, we see that that just equals the square root of c squared minus x squared, which is our f of x. So we showed that f of negative x was equal to f of x for all x that x could be. So all x in that domain, and that's what we needed to do. So into part C, we wanted to sketch a graph of f of x. So it gave you a couple hints. So the first one was to show that y squared plus x squared equals c squared. So that's our f of x is y. Then we're given that y equals the square root of c squared minus x squared. Squaring both sides, we get y squared equals c squared minus x squared. Add the x squared to both sides, and we get y squared plus x squared equals c squared. And this form should jump out as the equation of a circle, where the radius is c. And since we know that our original y was equal to the square root, we know that y is only positive, or it's positive or 0. So we're only going to have the top half of our circle. So if it's radius c, we know that it must have those intercepts. It's centered at 0 also, centered at the origin. So we must have those intercepts at x-intercepts at negative c, positive c, and then with radius c, the point, then we also have the point 0c. So that's how we get our sketch of f of x, and it is the top half of a circle with radius c. So moving on to problem 3. So we needed to graph our f of t, and we wanted to show a couple important points. We wanted to get the vertex as well as the x-intercepts. So the f of t that the Tuesday quiz had for 3a was 6t minus t squared. So our f of t attains 0 at some values. So it must have 2 zeros since it's quadratic. We say that f of t equals 0 equals 6t minus t squared to find those intercepts. So we can factor out a t, and we get t times 6 minus t has got to equal 0. So this gives us 2 roots. So the t, so this could be 0 if t equals 0, or inside that parentheses could be 0 if t equals 6. So then that gives us our 2 x-intercepts. Then to figure out the vertex, we've got some vertex form that we could use, which is our negative b over 2a. So let's write out just the general form of the quadratic, which we have here is at squared plus bt plus c equals our f of t. So if we look back at the f of t we're given and align those coefficients, so our a is going to be that coefficient of t squared. So we see that that's got to be negative 1. Our b is 6, and then our c is 0. So if we plug in 6 for b and negative 1 for a, we see that our vertex has got to be 3. And this should make sense because our vertex is going to be right between those two intercepts. Should be exactly halfway in between because our parabola is symmetric. So we have a vertex at t equals 3, and then we know that f of 3 is then equal to 9. So then this is our point 3, 9. We got our two x-intercepts at 0 and 6, and we have an upside down parabola because we had a negative a value. So then this is important. This tells us that it's concave down. Similarly, if we would have a positive a, we'd have something that's concave up. So if we go to, then that is our graph. So then going to 3a from the Thursday quiz, we're given that f of t was 2t plus t squared. So similarly, we can find those two intercepts. So when is f of t 0? So we said 2t plus t squared equal to 0. We can factor out a t again, and then we see that there's two values that can make this 0. We could have t equals 0 or t equals negative 2 to make the part in the parentheses 0. So then, based on those two intercepts, we should be able to look at that and say, okay, definitely negative 1 is our vertex because it's in between those two. The parabola is symmetric, so our vertex has got to be in between. But let's check this. Let's figure out the vertex with the vertex formula. So our b is negative 2 because that is the number, that's the coefficient of our t term. And our a is going to be 1 because that's our coefficient of our a term. So then plugging in those, we see that our vertex occurs at negative 1, which is just what we expected. So we know that a is positive, so then that should give us concave up. We know our two x-intercepts at negative 2 at 0. We figure out what the y value of the vertex is by plugging in that negative 1, and we get negative 1, so then our vertex. So we have our vertex, our two x-intercepts, and its parabola that's concave up at similarly as shown below, f of t and t. So then next graphs were a bit tricky. It was the absolute values. So for the Tuesday quiz, you're given that f of x equals the magnitude of 10 minus x squared. So because it's the absolute value, it's got to be greater than 0. There's no way around it. The absolute value makes all the negative values positive. So let's first consider, what if we didn't have the absolute value? So we say that y equals 10 minus x squared. So then our two intercepts, so we have 0 equals 10 minus x squared, and then that gives us that x has got to equal plus or minus 10. So that's our two x-intercepts directly in between them. That's our vertex at x equals 0. And that plugging 0 gives us 10. So we got our vertex, x-intercepts at plus or minus square root of 10. And then we have an upside down parabola because our a is negative. So let's apply the absolute value. So then, if we apply that to our y, every y value that's negative will become positive. So we get our same x-intercepts at 10, at negative square root of 10, and positive square root of 10. Same vertex at 0, 10. But now, what was negative before is now positive. So we see that this was our negative before, which now becomes positive. So then that gives us the graph of y equals the absolute value of 10 minus x squared. So then for the Thursday quiz, the function that you were given was f of x equals the absolute value of 1 minus x squared. So let's consider without the absolute value. We get x-intercepts at plus or minus 1, and we get a vertex at 0. So plugging 0, we get 0, 1. And then our two x-intercepts at negative 1 and 1. So then let's apply the absolute value. So then the part that was negative becomes positive, and that is flipped. So then that is our graph of f of x and x for f of x equals the magnitude of 1 minus x squared. So this, we have to make sure that these lines, they're not straight. This is a parabola. We don't want to make those lines straight. So it just makes those negative y values positive. So it's not to be confused with y equals the absolute value of x, which compared to y equals x, you would just have that line, and then applying the absolute value makes those negative y values positive. So then that's all for quiz 1. If you have any questions, please let me know during recitation, and I will try and answer them, or come to calc tables and ask away. Thank you. Have a great weekend. Bye-bye.